Okay, so here is a thing. This is one of these fake sort of Nagoya or diamond. Well, they're labelled as diamond, but they're really they're a Chinese manufacturer. I think they're an off-produce. Basically, they don't meet the quality standards to have the diamond or Nagoya name on them. So they're the sort of rejects, and they're picked up and then made into these. Now this is the base of a 7900, and you can see the font doesn't even have the Super Gainer font. I have another one which actually has the font here, which is another fake, of course. But I thought we'd take this one to paces. Now this is brass and then anodized. As you can see, there's the brass underneath it, and then it's anodized. So this is an entire solid piece of machined brass. This is a plastic insert that the top brass piece, which is this piece, which is soldered on, is sort of heat fit into the top there. Now the whole rest of the antenna screws on this thread there, which is super glued. I'm not too sure how that's supposed to make a good quality connection, but that's super glued onto that there, and then the rest of the antenna goes up with the leverage thing. But this is what's it, and inside here, can't see for the light, but there is a coil. Let me go and see if I can grab a torch to shine in there. So we have a bit of a torch. Now if I shine down the hole, you can see that there is a coil in there. Now if you look at the colour of material, it's not tinned copper. It's solderable, so it's nickel plated, something nickel plated. It's not magnetic either, because I did try a magnet on it, and it's pretty damn hard. So as you can see, it's not even, it's like they push it through, they trim it, and then file it off. Because if you look at the brass piece, you can actually see the filing marks. So they file it flush and then solder it. Obviously that goes through the hole into there, and the wire comes out slightly out the top and then is soldered, and that is what holds it in. And obviously, as you can see, that goes down to the bottom. But there's a centre electrode, so it's going round and into the centre electrode, because you've got the dielectric down the bottom there, which is the white dielectric found in there, and somehow it connects to it. Now that actually is the pin at the bottom there, actually is gold plated. So it's another peculiar one, but obviously it goes around the dielectric and comes around the side somehow. I mean, we can do a continuity test to check whether we have a DC to ground. Obviously there might be. Might just be a coil connected to the ground, pretty much like a CB antenna as such, where it's partly connected, so the electrode is partially connected up the coil to the top, or the inductor, and then the bottom portion is connected to the outside. But oh, hang on, no, let me turn my buzzer on. There's my buzzer. As you can see, it is. So if we try to the centre electrode, That's strange. So this portion of the coil is actually connected as a deadish, kind of a dead short actually. We're getting about 0.8 fluctuation. There's a capacitance in there somewhere to the ground, but the ground to the centre pin has no connection whatsoever. Sorry, off camera. As you can see, get a good connection. The ground is connected. Nothing dead to the centre pin, but ground is connected to that. Very interesting. So centre pin to the top, nothing. So there's actually no physical DC connection to the top. Let's try measure the capacitance. So where is my selectiveness? Right, we are in a capacitive load right now. 0.35 nanofarad between the centre pin and the casing. So there's a capacitor that is actually effectively decoupling it. Is there a capacitance to, let me just take let me get the full blade of me test probes out. To the centre connector, yes, we have 0.35 nanofarad between the pin and the output to the antenna. Oops, daisies. So that's 0.35 nanofarad. I wonder if you can get to see the meter readings here. .34 nanofarad, 0.3334 nanofarad to the casing. Let's see if we have a capacitance. No, it's a dead short. I mean, we're picking up a stray reading there, but it's pretty fixed reading when we wire it. And we take a reading between the centre pin and the side. I mean, if we take a, come back here. We take a reading from there to the edge. Oops. It's a dead short there. But to the centre pin, we do get a definite 0.35 nanofarad to the centre pin. So, somewhere down in the base there, it's capacitor coupled. How that comes out is another matter. I'm guessing that's heat inserted too, possibly. You probably need to knock it out, which means there'll be no way of reassembling this after one has done so. To be honest with you, I mean, this costs £17 from China. And you know, for £17, That is not too bad. I mean, obviously when you put the delivery to it, as I say, it comes to 20 quid pretty much bang on. But that's really not bad. Now here are the components. See, this is the spring that actuates the fold down area of the antenna. Now the spring is steel, but it's plated. I don't know whether it's plated with nickel or chrome or what it is, but that's a plated spring, and yes, that's going to rust. There's no doubt about it. Now I've checked this component, which is obviously this sits inside the other housing with a spring, boingy boingy, so it pulls the thingy bob down. This is connected together. Oh dear, what have I done with the little mini screw? It's connected by a little flat or straight, there it is, a little straight-headed grub screw, look. Not even a hex head, but that's a straight-headed grub screw, and that goes through the lever portion and whatever, and screws into the other side of it, which I haven't got in front of me at the moment. But this here, again, is brass, nickel-plated brass. Now this, I have got it here. There it is. There's the piece. You see, this is where it slots in. Now that in there is also nickel-plated brass. Of course. Oh, the spring! Come here. It's dancing everywhere. That slots into there. Now that is the only method of good connection going on in there, is effectively that. And as you can see, if I push that through, you can see it pop out there on that spring, and that's what's making the connections. So any form of corrosion or wobbling or dodgy whatever is going to affect that. Now I don't see how on an original one they would improve that. Maybe the tolerances are tighter or something, but that is nickel-plated brass, steel spring, steel screw. Both the spring and the screw are magnetic. Nothing else is magnetic. And obviously if you scratch some of the plating off, I don't know whether you can see, like on there's where it's been scraped off a little bit, it's actually brass underneath. So that's not too bad. It's not necessarily mostly strongly bound either. Obviously this part's brass as well. That part in there that's inserted into the plastic is of course brass, and that's effectively what would screw onto that, which would be the cap into there. So as you can see, that goes into there. It'll need heating up again, of course, to push that in, but it'll obviously need gluing and whatever else to happen on there to strengthen it. And obviously, as you can see, that would there's the threads that screw onto there, which effectively makes up that portion of the antenna. And this was obviously super glued together at the bottom here to hold it all in. So yeah, as you can see, that's partially threaded now into there. So as you can see, that is how they're assembled. So for £20 including delivery, that's not a badly built antenna. It's definitely due with improvements. I've not got a genuine 7900 diamond to take to pieces to compare it to. I don't necessarily want to buy £100 antenna to be breaking apart like this. So you know, there is potential for these antennas, but again, with a lot of people reporting that obviously this area gets corroded, it breaks, you end up with bad connections, and so on and so forth. I can see why that probably happens, because I mean, I can't get into the base of this at the moment without actually completely damaging the base portion. Obviously there's a coil in there. It's nickel plated, possibly brass, nickel plated copper, I'm not too sure. But that's not too bad. I mean, for the rest of the antenna, I have to say, It's pretty piss poor. Each element or each stainless steel, I have verified that the actual lengths are actually stainless steel, but they are ground with an angle grinder or a bench grinder, one of the two, on the tips of them. I'll tell you what, let me go and grab one of the elements. So, here we have the elements, as you can see. Now, this is the top element. As you can see, it's virtually identical, but it's not as clean as you'd expect it to be. So it seems to me like they're rejects. So they don't meet the high quality standards of diamond, and these are sort of thrown away or remanufactured effectively. Now, if you look carefully, here's one of the elements. If you look carefully on the tips of these, to take the burrs off, what they've done is they've ground them. They've ground a flat with a bench grinder. Now, what that has done is when that sits into the holes, for instance here, it wobbles, and when you tighten the grub screw up, well, the grub screw's out of this one. It was a missing grub screw when it arrived, so definitely quality assurance has failed. But as you can see, there is play in the hole, and when the grub screw's tied up, it's out of alignment. It's like this. Obviously, I've exaggerated that, out the hole, but while that's in there, it's bent, so that the old antenna's like a bloody bent banana as it goes straight. So the quality is definitely not there, because of the absolute terrible uneven groundings, or grinding of the burrs at the end of the stainless. It's worse on other elements than it is on others. It's like this one here. Let's get it into focus. As you can see, that's very beveled. I've taken the burr off. And the problem is that because when it slots inside each other here, there's not much, doesn't go in that huge amount. So if we mark it there, if you look, where is it? Where my fingernail is, that is how much goes into it. And if you look where the grub screw is, the grub screw is right on the tip. So what's happening is, because of that bevel, it's pushing it out to straight on the hole. So maybe a slightly larger gauge of this stainless steel, and this is actually stainless steel, believe it or not. Now the quality, wow, the actual, this is the inductor portion, this is the supposed capacitor. So let's take a measurement and see if we can actually measure the capacitance across this. I mean, my meter doesn't do a large capacitive read, but it might be in the low ranges to be able to take a reading. That's fluctuating. That's about 0.33, 0.34. Take the needles off. 0. There's a stray capacitance it's reading. Not humongously comforting to that this is a correct value, to be honest. But that's stabilised at 0.35 nanofarad, but without anything connected. Yeah, okay. So 0.35. Let's turn the prongs round, shall we? Point 3536. Yeah, there is a reading there. Pretty low. I mean, let's see if we've got a resistance. It shouldn't be having a resistance across it, because DC should not be able to pass through a capacitor. So we should get a sharp reading, or short reading, then nothing. But let's turn it around. Nope. Nothing. Okay, so DC doesn't seem to want to pass through it, although it should get a short sharp reading. Let's try and see what happens if we try to short it out. That should discharge the capacitor. Nope. Yep, meters there. No, nothing. Okay. So it doesn't pass DC. So it is a capacitor. 0.35 nanofarad-ish, but I don't know whether I can trust my meter's reading, capacitive readings, to be honest. Maybe. So yeah, I mean that's what the so-called fakes, and obviously the logo on the packet or whatever doesn't have a diamond in the E. It's just a straight, weird, whatever. It's different, you know. What do you call it? But I mean, that's supposed to be an inductor. This is the base. That's the base hinge, as you can see, where the little screw goes through. Threaded on one side, not threaded on the other. And this here is just actually like a piece of silicon hose. It's over the top there. I mean, this can be remanufactured and probably fitted in somehow, screwed and fastened directly onto the top. Move this type of thing, but maybe, as I say, it could be threaded. It'll reduce the length of the antenna, but seeing as this needs a new whatever, I mean, yeah, I wonder if we can get this bit of silicon rubber off and actually see. There we are. We can see the fully machined area there. There's a tiny lip for the rubber, and that slots into there. There is still quite a reasonable amount of material there. A thread and a fine die and tap on, let's say, a metric fine. I'd probably reckon probably a 10mm, maybe an M10 fine, and that could screw together, and that could be a screw, and therefore use that as a type of a union, which could then attach to the brass component to here to do that. Obviously there's so we have the coil, which is effectively coupled, DC grounded, and then obviously the center radiating electrode is connected to the base coil via a capacitor, I think, or what would seem to be a capacitor. I mean, obviously, generally with capacitors, if you start with one end, by the time it's charged up, you have a short, sharp run up, then it stabilizes. Then when you turn the terminals round, yes, you do, you get a zero short circuit prior to the current charging it up. Turn it round. But we don't. Let's remove the thingy bob. So we get very low ohmage there, which is effectively a short. Short that out. Nothing. Swap leads. Nope. So let's get on to capacitance. It just fluctuates on that. I'm not too sure the capacitor's actually making a good connection. There's probably a bad connection in the bottom of there, you know, to start with. But either way, that is how it is put together. And this plastic outset here is, I mean, that could be remanufactured. I could remake that in nylon. Get some nylon rod, and then work my way to the bottom of this to finally remove it. I'm sure it's probably stuck in there. It does look like it is, but yeah. So definitely not the best or finest build qualities, but it doesn't look too far bad, to be honest, for the price. So yeah, anyway, that is the so-called fake Diamond Supergainer 7900, taken to pieces, gutsed out, some form of testing. Obviously more work needed to be done to take it to pieces, because I definitely think I'm going to be taking this further to pieces. But it doesn't look too far off. So, okay, that's all. Anyway, catch you later, guys. 73s.